Hello, welcome back to 14 Minesweeper Variants 2. I spent like the past, 20 minutes just doing Liar, and the reason why is because we're going to be looking at a new section today, which is in, it's in here, it's in the N Prime section. So yeah, no ultimate mode. We're going for the special parts of the game here, and there are actually a lot of special parts of the game besides the main screen. You also have these fancy left side combinations. You also have this entire page dedicated to only encrypted and liar. You have this page for extra variants, which we'll go through eventually, maybe. And then we have the galleries, of course. Yeah, of course you have the galleries. Yeah. Alright. So, we're not gonna do the combination levels today, because hashtag and L for individual right side variants is pretty boring, and we already did that in regular AND. So where's N plus? Yeah, there's no N plus actually, which is weird, but you can't actually find it here. You can probably find it in the, yeah, you can find it here. This is where N plus is. So yeah, your EX with something else, and then same for the rest. There's LX here. Wait, what? Why is this all in like such random order? Oh, I guess because there's no LA. That's weird. There should be LA though. Where is it? Yeah, there should be LA. It's right there. I guess LA is not here then. It's somewhere, but I don't. What? Where is it? Just isn't here. Okay, fair enough. But alright. We're gonna look at the new extra variants today, which are E apostrophe, E prime, L prime, and E caret. That's a caret, right? And then we have E and L finally, which is very interesting. I don't know how this is gonna work. Is this like 3 grids? Is this 2 grids with one overlay on the other? No idea, but we'll look at it eventually. Okay, so E prime, self-referential. If a clue X sees n mines in the neighboring 8 cells, then the cell marked x equals n is a mine. What? What? Okay, so if a clue X, so if clue A sees n mines in the neighboring 8 cells, so A for example sees sees 2 mines in the neighboring 8 cells, so the cell A equals 2 is a mine. B also sees 2 mines in the neighboring 8 cells, so the cell B equals 2 is a mine. But since D equals 2 is not a mine, that cell D cannot have only 2 mines next to it. Okay, well, this is definitely something. Okay, let's see what the board looks like. What? Oh, I did not realize we had more pages. So here, A equals 4 is not mine. Okay, so it's basically the original puzzle overlaid on the other thing itself. Okay. So here for example, I guess since B equals 1, B equals 2, and B equals 4 are all like with mines on them, then B could be 1, 2, or 4 basically, is what you're saying. And D actually can't be any value at all other than like what? 5 and above. D could be 5 and above. In fact, D must be 5 and above because D can't be 0, 1, 2, 3, or 4. So, okay, so this could be D then. But A and B are wrong because A and B can't be 5. Wait, what? So you mean D can't be 5 either? Which means D just does not show up in the puzzle at all? Is that what you're saying? But question marks could have 5 cells around them because question marks don't have this inherent X property. Jesus, okay. So yeah, here B equals 1, B equals 2, and B equals 0. There is no B equals 0, but B equals 0 is still a mine anyway. C over here is 4, 4, and 4. C 1, C is 1. So C could be 1 or 4. C is also 0 for some reason. So it's one way, but not the other way around. Just because you have a mine there does not mean that one of the C's in the grid must have 0 mines around it. That's not true. But if C sees 0 mines, then the cell C equals 0 is a mine. Geez, alright. We got question marks here, which are... they're not like colored in, but I'm assuming that's because they're useless as question marks then. Okay. So I suppose... We can't just say that these are non-mines, right? Because... what color should I use? Yeah, light colors are not very nice. Let's do purple. Yeah, purple is fine. We can't just mark these off because A equals 3 and 4 could still be marked as mines, but I guess here because A equals 2 is not in fact a mine, then this A cannot be equal to 2 is basically what this variant would mean. Okay. And similarly here in this column, E is actually more useful here because E can only either be 0 or 2. Okay. Okay. This is really, really weird. How do I make any progress here? How many puzzles are there in this, like... Are there 100? There are 100 of these puzzles and I don't even know how to begin. What? Yeah, there's like zero logic I can apply here. Like the rule set itself is just that challenging already. But I mean, we all just know that this can't be a 2. If it were a 0, what would then happen? Then I suppose D equals 3 and 4 are not plausible. Which means that this can either only be 1 or 0. In fact, in that case, this wouldn't work then, because then D will be forced to be 0. But if D is forced to be 0, then there's a mine here which breaks D itself. So in the case where A is 0, you must have a mine here where D equals 1. And in fact, that is all that it can be, because D cannot have any more mines than that, which gives you this situation. But now E has no value. Oh. And E having no value is not possible because E is in the board. So E must have a value of some kind. And yeah, we already seen in the rule set that even if a clue had... clues can't have mine counts equal to something that isn't in the board already. So A and B can't be equal to 5 because 5 is just not in the board. Which is really interesting. But this fails, so we now know that A can't be 0. Which means A must be 1. So that's a mine. Jeez, okay. And since E is 0 or 2, this E must just be a 2 then. Yeah, because E can't be, this E can't be 0. Oh, well, if this E is a 2, then this is a mine. Okay. There you go. This is very slow progress, but I suppose since one of these are mines, we should probably use the fact that D is 3 or 4 to say that this must be 3 or 4. If it weren't 3 or 4, then it has to just be 1. That would happen. But then now this isn't a mine, which then breaks, because if D was equal to 1, this would then be a mine. So D is equal to 3 or 4. In fact, this D is 3 or 4. Okay. But which one is it? I mean, the more mines you put around it, the more it works. Right? Yeah. Suppose... I mean, this E is also a 2. I mean, I'm pretty sure about that. Because it can't be a 0, obviously, as a reminder. That really does affect, like, this area. Yeah, is it mine count? It's not mine count, is it? No, but notice that this area over here, this huge area over here, which I've drawn in, has exactly 2 mines in it. Because there's 1 mine in these 5 cells and 1 mine in these 4 cells. So if I could draw this area better, basically, this entire region, which looks like an E, which is really interesting, has an exact mine count of 2. How does that work out for the 8 remaining mines? I mean, there will be 6 mines in the remaining values, right? But there isn't any like rule set that says where mines can be. just says where mines must be. But mines can be anywhere they want. Okay. I think I have an idea. These are definitely mines. The reason why is because if any of them were non-mines, D is immediately equal to 3. And in that regard, whichever is remaining includes this mine and one of these mines. But if D is equal to 3, there's a mine there. And now that breaks this 2, which is seeing 3 mines. Which now means that these are both mines, therefore. Okay. So E can be 0, but there is no E equals 0. Anyway. So there's one mine here then, that's what I'm saying. Because if D is 3, then this is just empty, which works. If D is 4, then there's a mine here. So in both cases, you either have a mine here or a mine here, which means that none of these are mines. Okay, B finally comes in. B is at least a 1, you can see that. Not entirely sure how that's useful though. Okay, well if B is at least 1, then there must be some number of mines in here. And that would finish up the 2 for the E. So that's no longer mine. Okay. And whichever value of this has to be the only value that B can take. Besides 0. We still don't know if this is a mine or not. But if B was 1, that fails. If B is 1, then this is a mine, which puts 2 mines around B. So B can't be 1. Okay, you can't really see my cursor, can you? That's okay. If B was 2, hold on. I'm gonna go change the shading a little bit. What's the pointer color? There it is. Can I increase the Yeah, that's a nicer transparency to work with. Yeah, okay. Ah, look at that. So clean. Anyway, what am I doing again? B is either 2 or 3, right? If B was 2, then this is a mine which immediately finishes everything up. What's that break? I mean, maybe? This E means there's a mine there, means there's no mine there. 1, 2, 3, 4, 5, 6. Wow, and this does break, because even if you placed mines in all the remaining cells, you'd only have 9 mines in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, so that really means that B can't be 2, because that does force a lot of things to be empty. So B is 3. And because there can only be 1 mine here at maximum because E is 2. Yeah, because E already sees 1 mine, so E must be 2 because it can't be 0. And it only sees 1 mine here at minimum, at maximum, so that's a mine and this isn't. It's a classic 1-2 pattern. This E is a 2, so that's a mine that isn't. This E is 2, so that's empty, therefore these 3 are mines. Wow, okay. How is anyone expected to know how to solve this kind of puzzle? Oh dear. Yeah, this is gonna be an issue, isn't it? I don't know how I'm gonna like do this. Honestly. Should we try another one? So problem 900. Yeah, let's try another one. Okay, well. Okay, I can see that A is either 0 or 3 at this point. That is the most restricted letter so far. So, suppose... I mean, A directly affects E, which is interesting. Because the A's area does touch E quite a lot. Suppose A is not 3, then A must be 0, which gives you this. Now E can't be 4, so E here must be 0, which then fails. In fact, E is 0 just fails, because E is 0, yeah. Although this does not necessarily imply that this cell itself is not a mine. It could be a mine if other things were mine as well. But here, E can't be 4 or 0, the former because it doesn't have enough space, and the latter because if it were, it would just fail itself. And therefore this fails E in general, which means A also fails in general, which means that this happens. And this A can't be a 0, it must be a 3. So this A is a 3. Jeez, control. This A is a 3. How does that work? Don't know. Okay, this C is now at least 1. So C is either 1 or 2, right? C is either 1 or 2. No idea what that means. But it can't be 3, which is okay, I guess. So is this actually. This, yeah, because, yeah, C covering its own C equals 0 means there must be some number of mines. This is just a non-zero, basically. What happens if this was a mine? I mean, it doesn't really say anything. That's fair. I mean, if this is empty, maybe that's interesting. Because that does sort of force something that looks like this. Because it already sees 2 mines, this E must now be a 4. This can't be a 3. I don't know though. What? Like this, the idea of just this puzzle at all just blows my mind. Is there anything else I can do besides just trial and error with every possible value? I mean, D is the next most constrained, it appears. Cause like, suppose D is 2. I don't know. What happens if D was 2? Okay, I mean, okay, let's see. If C equals 2 is empty, then C can't be 2. So this C is equal to 1, meaning these are empty. And this C is equal to 1. Firstly, that means that this is a mine. And that means that that's empty. Now that fails because B no longer has a value. So this must be a mine. Okay. I mean, if this C was equal to a 1, what would then happen? There'd be some number of mines here. This also have to be a mine, which would be where the 2 comes in. Okay. If this was empty though, this C must be a 2, which means mines must be here and here. Meaning that this is also a 2. That now no longer means D can be 2 anymore. Which then gives you these values because A must be 3. And now E fails because E can't be 0 or 4. Oh, but E could be 3 though. So that could be a mine. I don't know. I need to figure this out like really soon. Alright, well I suppose B is at least a 2 at this point. So one of these are mines. Ah, okay, so well this C must be a 2 then. Okay. What was the previous thing that I deduced after that? If one of these were mines? There's one mine there. I mean, D sort of does something with that. Yeah, now D can't be equal to 2 because if it were, it would already see 3 mines. No, but it could still have a mine here if it had a mine here. Yes, then it could. Because it would then see 4 mines total. These are both empty. Right? Yeah, and like, I just want to make sure I'm getting the rules right here. Yeah, C can be equal to 0 even though none of the C's will actually see 0. So no negative constraint there. I feel like negative constraint would make things much easier for me, but I guess it's not there. So this could happen if this is a mine. Okay, what if this were a mine now? Then it fulfills itself. Adding a mine here would fail because now you need this to be a mine to fulfill anything, and therefore that would just overload itself instantly. D equals 4 also works actually, so we don't know about whether this is a mine or not yet. This however does also fail, so this is also empty. Is this always empty? If this is a mine, no, then D equals 4 would fulfill everything. But then A will be broken. Ah, okay, I see. One of these has to be a mine. So I think that just means that this must be empty. Okay. And now these D values are not the same. These D values are not the same. Look at that. They see a difference of at least one mine. So they're either 2, 3 or 3, 4 or 2, 4. Which is really interesting. Okay. I mean, 2, 4 works, we know that because this works. 2, 3 doesn't work though. Because 2, 3 would force one of the mines to see 4. So that means I think this has to be a mine. So it's either 2, 4 or 3, 4. Can it be 2, 3 and 4? No, because then clearly they would see 5 mines, which doesn't work. So there's exactly one mine here. And since A equals to 3, those are both mines. Okay, well, we're getting somewhere. We are getting somewhere. Okay. If B equals 4, then this must be empty because C can't be equal to 3. Therefore, these are both mines, which is fine. If B equals to 3, then these are both empty, and that fails because C now can't be a value of 1, but can really only be a 1 because of this C. So B can't be 3, B must be 4, which means these two are mines. D is 3 here, so that's a mine there. Okay, actually, I wonder how chording works. You can't even chord this, look at that, look at how dumb that is. You can't even chord this clue. Anyway. There you go. Jesus. Okay, well, all things considered, this is actually a really, really, really hard variant. I don't know if I want to keep trying this, or I think I should move on to the next, I think I should move on. Yeah, we're gonna move on. We've spent way too long on this variant, which I don't know. Alright, e to the power of encrypted stacked. Clues are encoded by letters. Each letter corresponds to 2 possible numbers, and each number corresponds to 2 letters. What? So it's just regular encrypted, but variables have 2 possible values, is what you're saying. Okay, so A2 and A4 are possible values for A. So each letter corresponds to possible numbers. So A could either be 2 or 4. Yeah, this A is a 2 and this A is a 4. Each number corresponds to 2 letters. Yeah, you can see here 4 corresponds to A and B. Wow, okay. Okay, and I can't chord at all for some reason. That's a thing. Is chording on? Chording is on, right? Yeah, clickable clues. Alright, sure. Okay. So... jeez. Okay, here's a question. Because letters correspond to 2 values, right? Aha! D can be 0. See, there are no clues in here that state that there are no D clues in here which are 0, but D equals 0 is still a valid solution to D. So yeah, that's plausible. Meaning that in this case, A can be 4, even though there are no A clues that are 4 neighbors, basically. Alright. Okay. I mean, I think the first thing we need to look at is differences, right? Because we can prove that something like C is greater than D, followed by D is greater than C, then we sort of have some understanding of like what's going on. See, but the problem here is that in regular encrypted, right, this is equal to C. So by regular encrypted, this should be empty, but because C can be also one more of its initial value, then it becomes possible for this to be a mine. Same here, where D and C imply that this should be a mine for C to be one more than D, but because numbers can have two possible letters attached to them, it's also possible for this to be empty and for C to equal to D as well. So rather than drawing the symbol where C is greater than D, it should be more like C is greater than or equal to D, which is really, really weird, I guess. But okay. If so, then I don't know. I really have no idea what to do here. I'm sorry. Okay, from this D I can tell that this D is either a 0 or a 1, because D can't be 2 firstly, and D can't be 3 because there aren't enough cells around it. So this is either a 0 or a 1. This B is also either a 0 or a 1, but they don't necessarily form a pair, because there is, you know, that and that. But D can be 0 and 1. Okay, I'm gonna use a hint to see what's going on. Oh, I'm so dumb. And oh my gosh. Yeah, every row and column now has 2. Okay. Yeah, because each number corresponds to 2 possible values. So these are both a thing. What is this? So this is either 4 or A, but this is clearly can't be 4. So this is the other value of A basically. Same here, this is the other value of B. So B is equal to 0 or 1 in this case, right? Which now means that these can't be mines. And for here, A is equal to 0, 1 or 2, so A equals 3 is not possible. Oh. Wow. But this could be 4. These could all be mines basically. That's what you're saying. Okay, well I can say A and 2 are definitely a thing. So this is now either 2 or 4, which clearly must be a 2 then. This is a 1, so B is 1. This is a 2 or 4, which means that it's just a 2. This is 2 or C. What is this? What is this? What is this nonsense? Okay, well, okay, we can start doing some special thing here. We do know that there is a mine here. Therefore, this value and this value differ by exactly 1, which means that the two values that C could be do differ by 1, meaning that C is either 1 or 3, followed by 2, so that can't be a mine. That can't be the truth, meaning that D and E share 0. It's either 0 or D's other value, which is 2. It's either 0 or 1 or 2 basically. So D is 3 is no longer a thing, meaning these are both mines, meaning that happens. Alright, and there you go. You can start solving the puzzle now. Okay, well clearly this and this cannot have the same value because one is 0, 1, the other is 2, 3. So they must differ by exactly 1. And in fact what that means is that the only way for these two values to differ by 1 is if it were a 1 with a 2. So there's exactly one mine here, is basically what's going on. This 2, 4 is interesting because this 2, 4 is definitely a 2 already, but would have to have at least one mine here as a result because of regular 2. That would imply this is a 4 because it can no longer be a 1. So these are all mines. That's empty. This 2, 3 would be complete because it's just a regular 2. There are 4 mines remaining, so these are all just mines. Wow, okay, so after I got that very first deduction, it wasn't that hard afterwards. But yeah, the first deduction that I made in this puzzle was a trivial one. It's just I did not realize that was a deduction you could make at all. Okay, let's try again. So here you can see in the column D is 1 and 2. So it's like encrypted, but instead of 1 per column and 1 per row, it's 2 per column and 2 per row. Okay, let's try that. So these can be different values. This can be 1 or 2. This can be 1 or 2. This can be 1 or 2. Right. I mean, A... This A has to be greater, right? This A has to be 3. Because if this A... No, wait, hold on, no. This A could be 1. Because if this A was a 1, then this would just be a 1, meaning that... Yeah, this A could also be a 3. In which case you would have 3 and 2. And then for your other value, A could also be 4. Doesn't matter. Alright, then what? I mean, B currently has no value at all, actually. And then C. Well, we know there's at least one mine here. That proves that this value is at least 0. But we can't say that the other values, unless we can prove that C has 2 different values and not 0. Yeah, we can't just say because this isn't 0 doesn't mean that this is not 0. Because it could be 0 plus like a 4. What is this? What is this? What is this? Okay, I think I got it. A can't be 1, or at least this can't be a 1. Because if this was a 1, then this 1, 2 would also have to be a 1. I mean, there's exactly one mine here. But that breaks C because C... yeah, because once A equals 1, C is no longer 1 because there's already 2 in the row. But now C also breaks because C can't be 0, there's already one mine here. And C can't be 4 because there's only one mine here, which means that you can never get to 4. So that fails C, which means that A can't be 1. I mean, this could still be a 1 though. It's just that this A can't be a 1. And if this A can't be a 1, it must be the next highest, which is a 3. So these are all mines, meaning that this is valid. This is the other value, which is, yeah, which means it can't be 4. Okay. So there you go. So now this C, well, C is just 0 or 4. This must be a 4 then. This must be empty. B here. You can do that? Why? Oh, because this can't be empty, because B can't be 1. There you go. Okay. This is a 1 or a 3. Well, there must be some number of mines here, so this will be the 3, which means these are both mines. This 2B means B must therefore be 0, because B can't be anything higher. Oh no, B can be 2. Wait, what? Oh, it's not. Okay, so now B is 2 or 3. Oh. What is this? This is actually kind of messed up. I don't know if I like this or not. Hold on, I gotta go find that Steam achievement. That one Steam achievement that said, find a board with a secondary solution but blah 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 blah. Is that an I thing? Yeah, win an I or an I plus puzzle whose secondary board is not uniquely solvable. Yeah, so that's not something I can do right now, but it's I. Okay, sure. Alright, well that was really dumb. I don't want to do this ever again. Let's do L. Okay, L is more normal. I read the rule set for L like just now, and it was much more normal than E prime or E stacked. I'm gonna call it stacked. Yeah, so liar. A liar is either 1 greater or 1 less than its actual value. That's regular L. Each row and column has exactly one non-liar. So of all the clues in a row and column, all of them lie except 1. So it's the inverse of regular liar. Alright, so let's begin. Okay, this 4 is clearly a liar. And these are all mines, okay, fair enough. I'll mark them off. Okay, one of these are non-liars. No idea what that means. Oh, that must be a non-liar though, because it's the only one left in its row. So that's a non-lie, which means it's telling the truth. Okay. So think about it, it's telling the truth. This must now be a non-liar, which is telling the truth, which is telling the truth. So that's a mine. And there's one mine in here. Okay. This is some really messed up logic, but okay. 6 mines remaining. Okay, I think this has to be a mine. If it was not a mine, then this is definitely a liar, which means that these are both mines because this 3 is only a 2, which now means that there are no non-liars in this column. So this must be a mine because that would otherwise break. Okay. What else can I do? So one of these are telling the truth then. If this was telling the truth, then this is just empty, meaning this is lying, which means this must be telling the truth. But that then means this is a liar, which only sees one. It can't see one more, so that's also empty. And this is the one final telling the truth, which means that these are both mines. That works. I don't know how many mines we have left though. I think we have enough. This is empty. Mine here. Mine. Actually, that's not enough because we only have 4 mines left and there are 5 mines remaining. So what was our original deduction there? That this was telling the truth. So this is, you're telling me this is lying and this is telling the truth? Okay, fine. Anyway, this is lying, that's a mine. Therefore, this is telling the truth, this is telling the truth. Therefore, that's a mine, that's empty. That's empty, that's a mine. That's a mine, that must be empty, and there you go. Yeah, so, yeah, this is actually a much more tame version. It's a much more tame, it's a much more tame variant of the variant. Okay, so this 6 is clearly lying. This 3 is telling the truth though. So this 0 must be lying. This 3, well, if this 0 is lying, it's possible there's a mine here, which means that this will be telling the truth, but there could also be a mine here, which means this will be lying. Both are fine. Okay, this 3 is lying, so there's one mine in here, and because this 3 is lying, and it already sees 3 mines, it must see one more, so that's a mine. Okay. One of these are telling lies, one of these are telling the truth. If this is a mine though, this is lying, which means there are no non-lies in this column, so that's empty, therefore this must be telling the truth. This is lying, so that's a mine. There's one mine here as a result. That's a telling a lie. Sorry, no, that's telling the truth, which means there's one mine here, which means that's not a mine. There's also a lie which sees one, so it must see another. That's a lie, and that's a lie. Oh, sorry, that's a truth, and that's a truth. Wow, I have no idea what I'm saying. But there you go. Oh man, yeah, this is gonna be a really tough set of puzzles for me. We need someone to teach me about self-referential, honestly. I think this is one I'm struggling with the most right now. Let's keep going. Alright, 6 and 1. Well, definitely, like, I think they're definitely both lying. The reason why is because in regular Minesweeper, the only way for 2 such numbers to be next to each other is if they have a difference of at most 3. Right, and that only is possible if you have mines here, here, and here, and then here, here, and here, because ignoring the common ground, this side will see 3 more than this side. Okay, but here we can see 6 and 1 have a difference of 5, which is way more than what is allowed. Now they must both be telling the truth, and that's because, they must both be lying, because if there is a singular liar, that liar has the ability to decrease that disparity by exactly 1, by going down a value of 1. And however, because they differ by a total of 5, you need to bring down the disparity by 2 to make it even remotely possible. And the only way to do that is if you have lying once and a liar twice. So they're both liars, which means that the disparity is exactly 3, which means these are all mines and these are not. Ta-da! Alright, that is the best piece of logic we've had in this video so far. Alright, this 6 is actually a 5, and this 1 is actually a 2. That's pretty obvious. That's the only way actually it can work. Anyway, one of these are telling the truth. If this is telling the truth, if this is telling what? No, this works, right? If this is empty, then this would be lying, and then this could be telling the truth, and then this could be a mine. The other way around is if this was telling the truth, then these are both mines which work. I guess that means that this is always a mine. Sure. One of these must be telling a lie. No, one of these must be telling the truth, sorry. One of these must be telling the truth, which means that number will be not a mine. Okay. Doesn't tell us much. Oh, sorry, this 3 is definitely lying. I just did not realize that. So now that's telling the truth, which means that that's also telling the truth, so these are both non-mines. There's one mine here because this one is lying. That's definitely a mine by just regular Minesweeper. This 3 must be telling the truth, therefore. This one is lying, this one is lying, so that's a mine that isn't. This 2 is lying, so it's done. This 2 is sorry, what was I? Yes. Okay, I mean, at this point, it's just really solid. It's just, these are both just mines. Ta-da! So, these are the liars? Oh, these are the truth tellers, sorry. Yeah, I keep confusing it with L and regular non-L. Oh my gosh. But there you go, that is L prime, which is a lot simpler than E prime and E stacked. Just saying, once again. Alright, let's move on to the very final section of this video. And that... sorry. Sorry. Yeah, alright, let's do one final one. EL. Oh gosh. Let's see how this works, shall we? Encrypted. I mean, it's pretty obvious how this is going to work. You're just going to have encrypted clues, but at the same time, some of them will be lying. That's really all. I just don't know like how much information you're going to need to make sure the puzzle is solvable. But okay, let's take a look at normal encrypted and liar first. Encrypted just means letters have a singular value each, a singular value. So each letter maps to a singular number, each number maps to a singular letter, and then you solve the puzzle like that. Liar means every row and column has exactly one liar. And I assume it's just identical. Yeah, it's the exact same. Okay. So we also can't be sure that C and D must differ by 1, right? Because they could be liars. They could be liars. But they must differ by 1, right? Okay, so this value is either 0, 1, or 2. What? Wait, why can't it be... Why can't be a 2 liar? Why can't D be 2 and also lying? Oh, because the board here is the liar board. So if D is 2, then this is a circle? Wait, what? Right, there you go. If D is 2, this is a circle, this is not, this is crossed out. And therefore this cell can't be lying. Which means that this just breaks. Wow, that is so meta. It's using the encrypted board as its own board. So like its position throughout the entire grid actually matters It just matters. Like, it's different. Yeah, that's really weird. So if you rotated this board 180 degrees, if you had a D clue here, the same deduction cannot be made. Because this cell does not interact with D in any way whatsoever. But because this cell does in fact interact with this column, it works. Wow. Wow. That's so cool. So this really just can't be 0. It can't be 2, I mean. It's a 1 by chording, I guess. It could also be a lying 0, yes. And that works because if it was 0, then this would be a circle, which indicates it's lying. Otherwise, it's a 1, which indicates it's telling the truth. Oh, okay. So that just means that all 3 of these are telling the truth, or all 3 of these are not liars. So one of these are liars. That's what I'm saying. Okay. Okay, if D was 0, then if D is 0, then this is 0, which is a liar. This is also a 0, but also a liar. So that's also a liar. Meaning that E will be 1 as a result. What could C be then? Well, this C is telling the truth. And must see something that... I mean, C could be 1. No, but C can't be 1. Yeah, C is a maximum of 2, so C will have to be 2 as a result. So you have a mind here. But that fails, because now you have a mind here and you're implying that the mind is lying, which isn't possible. So D can't be 0 then. Wow, that is actually pretty insane. Wow. So what is this? Can I call it? I can, but I can't really tell what C actually is. Wow, what? Can you believe this? Can you believe this? It's not even 3 bars anymore. It's just... Yeah, the very first thing I said, like, it's like the encrypted and liar board just like stack on each other. That is actually so cool. It's impossible. I mean, like, it's like pretty insane that you get to make puzzles out of this. But okay. This C is lying. Oh, but if it was a 0 or a 2, then either way it would be lying and therefore we'll only see 1 mind. So that's always empty, right? Yes. Why couldn't you chord that? Why could you not chord that? I guess because it's not like advanced. It's like a really challenging, perhaps a bit too challenging of a deduction for it to be counted as chordable. Okay, so if C is 0, then this is a liar, which means this will be 1. 0 is actually 1, so one of these are mines. A is telling the truth, so A therefore can no longer be 0. In fact, yeah, this just happens. A will have to be 2, 3, or 4, and therefore there has to be a mine here, so A will have to be exactly 2, which means that's a liar, which works. And then this C is also a 1 here. Okay, now that works so far. If C was 2, then this E is a liar. C is not a liar, so this would actually be 2. Then A, which can no longer be 0 or 2. B will be 0 then. Must be 3 or 4, but B can only be 3, so that's a mine. There's at least 1 mine here, so E is 4. I mean, that looks okay. But we know this is a liar as well. We know this is a liar, and we know that's a liar. Oh wait, this fails because this is a liar, which means that this can't be a mine. Wait, okay, so that fails, and where did that stem from? That stemmed from the assumption that C is 2. So C is not 2. C is in fact just 0. Okay, so there's 1 mine here, meaning A must be 2. There's a mine there. 0 is telling the truth, so there you go. 2 is telling the truth. E is 3 or 4, but this is telling the truth, so E must just be 3, which means that's a lie, therefore there's 1 there. This 3 is telling the truth, so that's there. Okay, okay. This B is just a 4, which means it's lying, therefore it could be a 5 though. It could be a 5. In fact, it must be a 5, because if it were a 3, then there wouldn't be enough cells. You need 4 mines remaining, so it is in fact a 5. This is a mine. This 0 is telling a lie, so that means that's empty, and therefore that's a mine. This is actually pretty cool. This is actually a really cool... Wow. Wow. Okay. Yeah, I don't know if that's gonna be it. That's actually like we might try a singular other puzzle. Let's do one more. Let's do one more. What? Is it this? I think it's this. Hold on. Can I call it that? I mean, yes, I can. I could probably call it this as well. So C is either 0 or 1. Okay. That would affect the value of E. No, that would not. Well, if C was 1, then this would be a circle, so E would be 4. That is actually an equivalence here. Okay. I'll say it might be this, but like, if D was 3, then this will ultimately be lying. It could be a 4. Doesn't really say anything about itself. Maybe these, because these are closer to the lower B values. Like, if B is 1, then this must be lying, which means because this is no longer a mine, this B is lying, so A is 0. And that fails because C can either be 0 or 1. So B can't be 1. Okay. If B was a 0, then C will be lying. This B will not be lying, so that will be empty. This C will be lying, and because C is 1 is lying, C could be a 2. This will be so this will be empty, this will be empty. This will be no. 2, 4 forms its own pair. You get something that looks like this. D is equal to 3, in fact, meaning that's a lie. C equals 1, meaning that's a lie. So E is 4 and A is 2. That's fine though. I mean, I can additionally then conclude that this C must be a 1 that acts as a 0. Yeah, because if it were acting as a 2, then you have a mine where a circle is. So you have this and this. Which is a lot of empty cells. Yeah, so then you have a lie here and lie here. This will be a liar, and then it's going to tell the truth because B is 0. What? I mean, this B is also telling the truth, so these are all empty, these are all empty, these are all empty? Okay, then that clearly fails because you don't have enough space. So what, are we just then saying that the C equals 1 fails, or B equals 0 fails? Wait, where did that come from? Yeah, B equals 0 fails then. I mean, sure, that's so random. Anyway, this has to be a lie, so A is 0. This is a mine, therefore. C is telling the truth, and C is in fact 1, D is 3, E is 4. So that's empty. 3 means they're both mines, that's empty. Okay, I think I solved the puzzle from here. It was just that singular deduction, I guess. This must be a mine, this must be a mine, this must be empty. 2 mines remaining, so both mines. There you go. This is so cursed. I went from saying this is a brilliant idea to thinking that this is not very brilliant at all anymore. You gotta think so hard for this one. I don't know how I'm gonna work with this, but this is pretty interesting. Alright. Well. Okay. Well, with that, I think I'm gonna end the video here. Yeah. This was a really cool episode. I hope you enjoyed this video. I'll see you guys next time. Bye bye.